Hello, we are Jenny and Raul, and we are going to present about supernova, where we cover the different types of supernova, their characteristics, and the processes that lead to these powerful stellar explosions. Supernova explosions are spectacular and the most dramatic events that take place during the final stages of the death of a supermassive star. After a supermassive star has begun to die, it goes through various stages of fusing different elements, forming a red supergiant. Once the core mass dips past a certain threshold, it collapses under its own gravity. This catastrophic collapse leads to an immense release of energy, causing the outer layers of the star to be ejected into space in a brilliant explosion. The aftermath of this explosion can result in the formation of either a neutron star or a black hole, depending on the remaining mass of the core. The debris from the supernova can also seed the surrounding interstellar medium with heavy elements, contributing to the formation of new stars and planetary systems. Type 1a supernovae are characterized by the absence of hydrogen in their spectra. These events occur in binary star systems, where a white dwarf star accretes materia from its companion. This type of supernova shows little or no hydrogen and an excess of elements like carbon, silicon, calcium, and iron. Once the white dwarf reaches a critical mass of around 1.4 times the mass of the Sun, it, it undergoes a catastrophic implosion, leading to a powerful explosion. Type 1b supernovae form when a massive star collapses under its own weight. This type of explosion, also known as a stripped enveloped core collapse supernova, occurs after the star has lost its outer layer of hydrogen but retains some helium. The collapse and subsequent explosion of the core result in a dramatic release of energy and light. Type IC supernovae occur when a massive star explodes after losing both its hydrogen and helium layers. The supernovae are similar to type IB but are distinguished by the complete absence of helium in their spectra. Additionally, type IC supernovae lack the silicon line seen in type IA spectra. These stripped enveloped core collapse supernovae reveal the inner layers of the star, primarily composed of heavier elements, providing valuable insights into the late stages of stellar evolution and the processes leading to such explosive events. Type 2 supernovae are distinguished from Type 1 supernovae by the presence of strong hydrogen lines in their spectra. The supernovae occur when massive stars, after fusing elements up to iron, can no longer sustain fusion in their cores. This leads to the gravitational collapse of the star's core, followed by a violent explosion. The aftermath of a Type 2 supernova can result in the formation of either a neutron star or a black hole, depending on the remaining mass of the core. Classification: Type 2b supernovae. These supernovae are marked by an initial plateau in their light curve, indicating a prolonged and steady release of energy, followed by a normal decline in brightness. The plateau phase results from the combination of hydrogen in the outer layers of the star. While type 2L supernovae, the luminosity of this supernovae linearly declines following the explosion, unlike type 2P. Type 2L supernovae do not exhibit a plateau phase, and their brightness decreases at a more constant rate over time. Thermonuclear explosions. This type of explosion does not occur when the core of a massive star collapses. Instead, they happen in a binary octave star system. To trigger a type Ia supernova, one of the two stars must be a white dwarf. The other star is often a low mass star, like our Sun, or can be a red giant star. The white dwarf accumulates matter from his companion star, and once it reaches a critical mass, a thermonuclear explosion ensues, leading to a type Ia supernova.
The fifth step begins with the core's inability to support itself. It is weakened by the emission of photons and neutrons that occur inside the core. Think of the core as a balloon inside another balloon. As the inner balloon fills with water, it affects the other balloon. If the inner balloon reaches a point where it bursts, the other balloon will support it, but if it continues to fill, it will eventually burst away. A similar process happens with the core of a supernova. The second step begins with the photons and neutrons trying to escape from the core, which they eventually manage to do. The way the wind escapes through a massive explosions. The final step is what many people know as the explosions. In addition to the explosion that disperses on the materials within the supernova, it also releases a shockwave that resonates throughout the cosmos and can last for thousands of years. One of the ways to detect supernovas is through cosmological mass changes, neutrino detection, quasar disappearance, and radiations. There are complex parameters to understand, but basically, they will increase the events and Jensen's as shown in the graph. This graph represents the temperature at certain periods and the energies released by neutrinos over a given time. Supernovas have been observed thanks to the James Webb and Hubble telescopes, which have provided the best resolutions of these events. However, if someone wants to observe them from home, they would need a special optical telescope or a radio telescope. The importance of studying supernovas is because they generate materials that handle for the formation of celestial bodies of even life in the solar system, as happened with the Earth. Therefore, the phrases "night in the veins, the mate of stardust" is not that incorrect. The supernovas can be night circles because they leave a trace of their existence in the form of nebulae stars or neutrinos. By calculating the time since a supernova occurred, it is possible to estimate the age of certain celestial bodies. Thus, it can be said that they help determine the age of objects in space. Another importance of supernova is that they add a gauge because the immense explosion generates an incredible burst of light. This burst of light can help us determine the distance between celestial bodies. It plays a role similar to quasars, which can measure distance between objects. When to finish the presentation, I just have to say that supernovas are an interesting phenomenon that handle for the existence of life in our solar system, but they also help us understand how the cosmos functions. Therefore, it is important to cultivate curiosity about supernova and promote knowledge of them so that future generations can continue to contribute to this find.